Hey, welcome back to the series on Advent of Code 2023. Today we're getting stuck into day 6, which is all about boat races. So the input file for day 6 is 2 lists, one with time and one with distance. And it's all about these little toy boats, right? And the way that the problem is phrased is this is a race. You have 7 milliseconds to run the race in total, and you have 2 options. You can hold down a button, which increases the speed of the boat, or you can let the button go, and then the rest of the time in that race, the boat moves forward at whatever speed is built up. And your goal is to beat the current record distance, which in this case is 9 millimeters. Everything in this problem is millimeters and milliseconds, but we got 3 races here. One that goes for 7, one that goes for 15, and one that goes for 30 milliseconds. And we've got to try and beat these records. So there's a little bit of an explanation here about, hold it for 0 seconds and it doesn't move, so nothing happens. Hold it for 1, it moves for 6 seconds. It's pretty basic stuff. I'm not going to bother going through all this. But the key takeaway from this analysis is that there's multiple ways that you can beat the record. And the way, or the input or the answer for part 1 is what's the total number of ways that you can beat the record? Notably, we can only do things for complete milliseconds. So it's like 1, 2, 3. You can't do 1.5 milliseconds of button holding. So for every integer value, which of them exceed the current record distance? So this problem I find really interesting because it's one where on the surface you could pretty quickly jump in here and iterate through all the possibilities. 7 examples, 15 examples, 30 examples, pretty easy to do. But with a little bit of planning, you can make this code pretty simple and pretty widely applicable. So let's jump in and look exactly what that looks like. You'll see here, this is the whole thing, parts 1 and 2. It's actually a really simple problem if you take the time to break down what's involved. So we parse the input file. 6b is what I use for part B, but we'll get to that. Read it into a string, split up the values into 2 lines. We know there's going to be 2 lines. There's a 3rd line for the empty line at the end when I copied it across. We got the time line and the distance line. We strip those 2 string values out, split everything by spaces, and say, hey, that's our values. And then we zip them together and loop through. Now, the thing to understand about this problem is formulating it and slowing down and having a little bit of a look at the problem itself makes this one pretty quick to solve. So let's talk about it. We have some number of milliseconds, let's say that's stored in a variable called time, that we have to play with. And we can think about how long we hold the button down as some value, x. And we say, look, the speed our boat's going to travel at is x, because we've held our finger down for x seconds. If we want to know the distance that boat is going to travel, it's whatever time is left, so the time minus however long we held our finger down, x, times the speed, which in this case is the value x, because the speed builds up at 1 millimeter per second per millisecond. I don't know why they didn't use meters and seconds. It'd be a lot easier to explain. But if we expand that equation, we see that the distance we travel is the total time multiplied by x minus x squared. Now, what we're trying to solve for is when we're exceeding a constant value of distance. So in that first example, 9. So another way to look at that is when does time multiplied by x minus x squared minus the offset distance, the distance we have to beat, when is that greater than 0? Now, if you recall from way back when in high school math, this is a quadratic. This is a second order polynomial where we have x squared, some value multiplied against x, and then a constant, in this case, the distance. And because we're looking for the points where it crosses the x-axis or y equals 0, we can find exact solutions to these using the good old handy quadratic formula. So for those who have not used this in yonks, the quadratic formula is minus b plus or minus the square root of b squared minus 4ac, and then all of that is divided by 2a. Now a, in this case, is -1 because that's the value in front of x squared. B is the value for time, and c is negative distance. If we solve for x in this case, we're going to get two values, and then knowing those two values, we can say, look, any values in between these two, because if you remember a quadratic, let's say it's going up, it goes up, and then it comes back down, so it will cross twice. Anything in that range will exceed the current best distance for that particular race. So that's what we do. We say, look, A is -1, B is time, C is negative distance. We calculate the two roots of that equation using this formula here. Add a little tiny offset because we need to do some integer stuff here, but you can probably drop this. But we're going to get two roots. We then round the lower root up and the upper root down because, as we said before, it can only be whole numbers. So let's say one of those roots is at 1.5. Well, we can't hold it for 1.5 seconds. So we either need to hold it for 1 second or 2 seconds. So depending on whether it's the lowest possible value or the highest, we need to pick one and round to it. But we do that rounding. We then add 1 for the space in between because it needs to be inclusive. And that delta is now going to be a 64-bit float, but it's going to be indicative of the range of times in milliseconds in which we will beat the record. Our job then is to multiply all those values together to give the final total for this problem, which then in the first case is 588,588. So pretty quick here. You definitely could have, looking at the input values for part 1. So let's just have a quick look at that now. Day 6 input, look, we don't have a ton. See, we've only got 1, 2, 3, 4 different values and then 4 different distance values to beat. You could very easily do 44 iterations, 82, 69, and 81 and calculate the number of times you beat 202, etc., etc. Where this becomes problematic is in part 2. We're now at the part of AOC where part 2 tries to throw a bit of a curveball at you. In this case, part 2 says that the people who wrote the input file actually are just bad at kerning. They put a bunch of spaces where they shouldn't have, and it turns out there's actually only one race, and you just need to remove all the spaces in between numbers, and that gives you the data for that one and only race. So if we go back to our terminal here, I did this by hand because I couldn't be bothered to join the stuff together, but we've got this many milliseconds, 448, 26981, and this is the distance that we have to beat. Now you can imagine doing that iteration, doing that test for, what is this, 4 million odd, if I've got that right? No, 44 million different checks is a little bit longer than doing it for 44. Lucky for us though, because we've taken the time to slow down, have a look at the problem and use some good old high school maths, we can apply exactly the same process to this much larger version of the problem. And ultimately, we do 2 calculations. Luckily, all these numbers still fit in a 64-bit floating point number. We get our range. We times it, but there's nothing to times. There's only 1 in this case, so we times it by 1, and then we print that answer. And doing all that, we get the very nice 34655,848 as a very quick, very efficient solution to part B of this problem. So I like this one because I think it really highlights the value sometimes in slowing down a little bit, working through the problem, maybe not on the computer, and not necessarily diving into code as soon as you see something you can solve. Now, yeah, look, you could have done part 1 and refactored into part 2, but I like these examples where a little bit of planning, a little bit of thinking helps us solve the puzzle in a really elegant and efficient way. So for a shorter than usual video, that is day 6, Advent of Code 2023. I really hope you're enjoying these. If you are, consider subscribing. But otherwise, I'm Elliot. I build stuff, and I will absolutely catch you in the next one.